Welcome friends and welcome to my series of video lectures on design of steel structures. The topic of this video lecture is design of a bolted connection truss joint. For best video quality, watch on laptop or desktop with the resolution set to 1080p, that is HD quality. The expected learning outcome from this video is design a bolted connection for a truss joint. Some key terms are used in this video: truss joint, gusset plate, bolt value, single and double shear capacity of bolt, bearing capacity of bolt, continuous and discontinuous member of truss, single angle and double angle truss members. Our best friend Smarty wants to suggest us some smart study tips. Write down your own notes while watching this video. Secondly, pause and rewind the video whenever required. Thirdly, do solve the formative and summative assessment quizzes in the video. In this video lecture, we are going to study the design of a bolted connection for a truss joint. We will be solving a complete numerical problem. So statement of the problem is a truss joint is subjected to forces on members as shown in the diagram below. Design the connection using 16 mm bolts of grade 4.6 by assuming the members AB and BC as A continuous and B discontinuous at the gusset plate. This is the statement of the problem. This is the diagram given. Here we see another diagram which is a picture of a real life joint of some 5 angle sections, single angle sections connected to a gusset plate shown in red here. So you see that this is a real life picture. Here we see that the bolts are there. All the angles are single angle members. Similarly, here also we see a picture in which we find a truss and here we find a bolted joint. Now let us concentrate on this diagram which is given as a data to us, and with reference to the diagram and the statement of the problem, let us understand the problem and the interpretation of the data. The first thing we observe in this diagram is there are 4 members, truss members, AB, BC, BE and BD. 4 members are there. Now out of these 4 members, we are having this AB and BC, these 2 members in a straight line, and they are made up of double angle section. 2 angle 95 by 95 by 8. Here also 2 angle means Indian Standard Angle section ISA, 2 ISA 95 by 95 by 8. This 2 in the beginning indicates that these are 2 angle sections which are connected on this side of gusset plate one angle and the other side of the gusset plate second angle. So from this view we are able to see only one angle, but from the other side also there will be another angle, and we will be having this double angle section with the gusset plate in between. So this is about AB and BC. Now if you look at BE and BD, we find that both of these sections are single angle sections. How can we say that? We can see this designation. This is Indian Standard Angle 50 by 50 by 8. Since there is no prefix like 2, it means that it is a single angle section. So both of these angles sections are single angle sections. So we have got 4 members, 2 members are double angle sections and 2 members are single angle sections. All of them are connected by a gusset plate. This is a plate which connects the angles or the sections of the members at a joint. Now we observe one more thing. If we see the center lines of all the 4 members, they are shown here like this. You can see the dashed dot line. If we extend all these 4 lines, these intersect in a single point. That means the lines are, or the axes of these sections are concurrent. So, and the forces that are acting on these members, 93 kilonewton, 105 kilonewton, these are the given forces. They are acting along the center lines. So we can say that this is primarily a problem of four concurrent forces. So these sections or the members are so aligned that they are concurrent. They make a concurrent force system. So this is the data that is given to us. Now we will proceed for analyzing the data for 16 mm bolt. It is given in the problem that we have to use 16 mm bolts of grade 4.6. Now this 16 mm bolt has got this numerical data, as we know. Whenever we talk of a bolt, the bolt comes along with its all numerical properties and data. So the first thing is it is 16 mm bolt, so 16 mm is its nominal diameter. That is what we call as D or D0. Now net bolt area, from the cross-sectional area of the bolt, we calculate its net bolt area, which is the cross-sectional area at its thread, which is less than the cross-sectional area at its shank. So we know that it is given by ANB, where N stands for net and B for bolt. This is given by 0.78 into AG, where AG is the gross cross-sectional area, that is the cross-sectional area at the shank. So this works out to be 0.78 into pi by 4 into 16 square, where 16 is the diameter of bolt. So this amounts to 156.78 mm square. Second dimension about the bolt is the bolt hole. So we have to make a bolt hole in order to insert the bolt, and we know that the bolt hole has to be little bigger than the diameter of the bolt itself. So the diameter of hole in this case is going to be D plus 2, that is 16 mm plus 2, that is 18 mm. Next, the pitch of the bolt is given by 2.55 D. So this is 2.5 into 16, that is 40 mm. Then the edge distance of the bolt E, it is 1.5 into DH. So this is 1.5 into 18, where 18 is the bolt hole diameter. So this amounts to 27. Rounded off is the figure 30 mm. Now we are already aware that while calculating the bearing strength of a bolt, we come across a factor called KB. So this KB factor depends, its value depends on the least of four values. So these four values are like this: E upon 3D, P upon 3DH minus 0.25, FUB upon FU, and 1.0. So we have to calculate these four values and we have to find out the lowest or the least value of the four. Now E, D, P, DH are the four things which we have to substitute, which we have already calculated in these earlier calculations. So E is edge distance, D is the diameter of bolt 16 mm, P is the pitch, and DH is the bolt hole diameter. If we put these values in these small formulae, we get four values. These four values are 0.625, 0.49, 0.97 and 1.0, and the least of these four values happens to be 0.49. So the value of the factor KB is going to be 0.49. All these values related to the bolt are required to be used in the calculations that will follow. Now we will proceed for step 1 of our solution. So step 1 is calculation of bolt value. By now we have already solved 2-3 problems of the design of bolted connection. In every problem, step 1 is the same. You have to calculate the value of bolt, that is bolt value, that is the value of the force that the bolt will resist, a single bolt will resist. Now that value is calculated as the least of, the smallest of two values. The first value is the shear capacity of the bolt and the second is the bearing capacity of the bolt. So these two values we have to calculate for a single bolt. Before we proceed for calculation of these the the bolt value, initially we have to decide the thickness of this gusset plate. The angles are already given, so their thicknesses and their dimensions are already given as data, but the thickness of gusset plate is not mentioned as data. So required thickness of gusset plate shall be greater than thickness of angles. The IS 800 2007 imposes only one condition about the thickness of gusset plate. That condition is that the thickness of gusset plate should be greater than the thickness of all the angles. So if we see here, all the angles are 8 mm thick. In this 95 8 or 50 8, this 8 represents the thickness of the angle section. So we have to provide a gusset plate having its thickness greater than 8 mm. So we will provide gusset thickness as T equal to 10 mm. So here this blue gusset plate, we are calling it as the 10 mm thick gusset plate. That is the first thing. Now we proceed for the bolt value, which is the list of VDSB and VDPB. Now each bolt can be in single shear or double shear depending upon whether it is single angle section or double angle section. So if we'll concentrate on this BE or we concentrate on BD, they are made up of single angle section. So this is single angle section connected to, so one leg of this section will be connected to the gusset plate. So it is like connecting two plates. So the bolt will connect the two plates. So when a bolt connects two plates, it goes in single shear. So we will say that this BE and BD, these two angles are single angles, and that is why they will have bolts in single shear. Now on the contrary, if we look at AB and BC, we know that they are made up of double angle sections. So since they are double angle sections, the bolt will be subjected to two cross sections of shear at a time. So the bolts for AB and BC will be in double shear. So actually this problem of four members connected to a single gusset plate is a problem of four separate connections with the gusset plate. So it is like four small problems. So in the two problems with single angle section, we will get single shear, and in the other case AB and BC double angle sections, we will get double shear. Now while solving this problem further, in order to calculate the bolt value, we will have to consider single shear capacity of one bolt as well as double shear capacity of one bolt. So we will calculate here both the values. In other problems, we were considering only one, either single shear or double shear, depending upon the actual situation. But here we have two members in double shear bolts and we are having two members in single shear bolts. So that is why we will calculate single shear capacity of one bolt here first, as the formula is the same, no difference, 0.462 FUB in NANB. So we will substitute the values. FUB is the ultimate stress in bolt, which is 400. We know that for 4.6 grade bolt we get FUB as 400 Newton per mm square. NN is 1 because we are considering one bolt, and the ANB as we have calculated here is 156.78. So with this calculation we get 28.98 kilonewton as the single shear capacity of one bolt. Similarly, double shear capacity of one bolt will be calculated by the same formula. The values will be the same, except that here while putting the value of A and B, we will be multiplying that 156.78 by 2, because for double shear we are having two cross sections subjected to shear, and that is why this A and B will be 2 into 156.78. So this will amount to double the single shear capacity, that will amount to 57.96 kilonewton. So this was the single shear and double shear capacity of the single bolt. Now the third thing is bearing capacity of bolt. The formula for bearing capacity is VDPB equal to 2 KB DTPFU. So this is, as usual, we'll put all the values as they are. 2 into KB. KB we have calculated here as 0.49, that we will put. Then D is diameter of bolt, that is 16 mm. Then we will have thickness of plate. Now thickness of plate is this thickness of gusset plate that we have to put. So this is 10, and 410 is FU for the plate, which is 410. This is not directly given. So when that FU of the plate is not directly given, most commonly we use the grade FE 410 for the plate. So we will always assume it as 410. So by the substitution of these values, we get the value of VDPB, that is the bearing capacity of bolt, as 64.3 kilonewton. Now at the end of this step, we calculate the bolt value for single shear separately and bolt value for double shear separately. So bolt value for single shear will be the least of these two values. So this finally we get least value as 28.98 kilonewton, and for double shear the bolt value will be least of 57.96, this value, and the other value 64.3. So the least of these two values will be 57.96 kilonewton. So we get two bolt values, one for single shear and the second for double shear. We find that in both the cases the bearing value is greater, and that is why it doesn't come into consideration. The smaller values are the shear values only. So this was step 1, in which we calculated the bolt values for single shear and double shear. Once we have calculated the bolt values like this in step 1, step 2 is very simple. So we will proceed for step 2 now. In step 2, we will have two parts. As we know, in the statement of the problem, we have got two questions, two parts. The first part is about ABC to be continuous, that ABC member is continuous. So look at this diagram. Here we find ABC as a continuous member. So we will design first this as a continuous member. Now let us proceed. We have to design 4 members, and we know that to design the connection of any member means to calculate the number of bolts required for that connection. So we will start connection between single angle member BD with the gusset plate. So look here. So this is the single angle member BD. You can see this single angle member BD, and this is the gusset plate. So we will first consider the problem of BD connected to the gusset plate. So number of bolts required to transfer the force N. This formula is the same. It is TU upon BVS. Now we have to be careful about taking the right value of the bolt value. That is, whether to take single shear or whether to take double shear. Now since we are talking about the single angle member BD, we know that the bolts here, all the bolts are in single shear. So we have to take BVS, which is 28.98 kilonewton as calculated in the step 1. So you can see here that this is 93 kilonewton upon 28.98. So this amounts to 3.2 bolts, and 3.2 bolts means we have to round it off to 4. The 3.2 is to be rounded off to 4, and we get this as this member BE subjected to 93 kilonewton force, and it requires 4 bolts. So we get 4 bolts. So this is the conclusion. So we have seen these 4 bolts here, 1, 2, 3, 4. Of course they have to be accommodated within the gusset plate because they have to connect the angle leg to the gusset plate. So these are the 4 bolts. Now we come to connection between single angle member BD. Earlier it was BE, single angle member. Now we consider this as BD with the gusset plate. Again the bolts are in single shear. Now the same formula applies here also. TU upon BVS. Here S stands for single shear, So this TU in this case is 105. So this is 105 kilonewton upon this is 28.98. So this amounts to 3.62 volts. Again, it is not possible to provide 3.62 volts. It is therefore rounded off to 4. So here also we require 4 volts. That is the conclusion. So for connecting this BD to this gusset plate, we require 4 volts of 16 mm phi in one line. So these two members, their connection with the gusset plate has been now designed. Now we come to this last. This is ABC. Now connection between member double angle. This is a double angle member, continuous. We are designing it as continuous ABC with the gusset plate. Now we have to understand certain points here. This is a continuous member and a force of 180 kilonewton is acting from this side and force of 285 is acting on this side. Now what will happen to the bolts which will connect this continuous member to the gusset plate? We will understand that the resultant of these two forces, 285 towards right and 180 towards left. So the final force, net force at this for this joint at the point B will be like this. So net force acting on the bolts TU in this case will be the resultant of this. So this is 105 kilonewton. So this will be 105 kilonewton. How it comes? It is 285 minus 180. So 285 minus 180 amounts to 105, and this is what is the net force here. And for that we will have to calculate the bolts. Hence number of bolts N for this continuous member ABC will be TU upon double shear bolt value. So this BVD we have to take. So this will be 105 TU upon 57.96. So this value is to be taken carefully. This is a typical source of a mistake. So this division will give us the value 1.8. It means that you require 1.8 bolts. So obviously we will have to round it up to 2. So it means that we will require only 2 bolts at this joint if this ABC is considered to be continuous. So even though the values of the forces are so much, the resultant force is only 105 for the bolt connection, and that is why this is the solution that we will require 2 bolts here. So if you look at this entire diagram now, this is the diagram showing the detailing of the bolts also. So 4 bolts for these 2 members and 2 bolts common for ABC together. So in this way we have designed this bolted connection completely for the situation where the bolts of the member ABC is continuous. Now in the next step, next part, we will consider the member ABC as 2 separate members AB and BC. So let us consider step 2B. Here it is the design of connection with AB and BC as separate discontinuous members. So if we look at this diagram here, we will see AB and BC to be broken in between. We see the blue, small blue portion of the gusset plate in between, which means that AB and BC are discontinuous. Now when they are discontinuous members, AB becomes a separate member, BC becomes a separate member. So they become similar to this BE and BD members. So we have to design this BA member separately and member BC separately with these forces as the forces acting as shown. So this problem, otherwise this BE and BD, they are as they are. There is no change in their design. So that design stands as it is. Now we will have to consider BA and BC as 2 separate members. So connection between double angle discontinuous member BA. So BA with gusset plate. Now bolts are in double shear, that we have to note. That is why, so we will get N is equal to TU upon BVD. What is TU? For BA, it is shown here, it is 180 kilonewton. So this will be 180 upon 57.96. Again, be aware of this value, substitute it properly. So this will work out to be 3.11. So we require 3.11 bolts. So rounded off to 4. So we can say that we require 4 bolts to connect BA to this gusset plate. So these 4 bolts are shown here. Now coming to the second BC, connection between double angle discontinuous member BC with gusset plate where the bolts are in double shear. We have N equal to TU upon BVD again. The value of TU is to be taken as 285 upon the value of BVD is 57.96 as seen here. So this value is 4.92. So you require 4.92 rounded off to 5. So you require 5 bolts to connect BC to this gusset plate. So this is the final diagram of the connection where we find 4 bolts for BA and 5 bolts for BC. You can compare this with the earlier situation where ABC was continuous. When ABC was continuous, they required together only 2 bolts to connect to gusset plate. Whereas when they are not continuous or separate, then they require, one requires 4 bolts, the other requires 5 bolts. So totally the connection requires 9 bolts in comparison with the 2 bolts. So here the benefit or advantage of continuity of member whenever possible is automatically highlighted. So whenever possible we should have the continuity of the members at the gusset plate. So like this we have considered the design of connection for the second part, or by considering the discontinuous members also. Now before we conclude, as usual, we will have a formative evaluation self-test. So pause the video and write on a paper the answer of the following question. Now the question asked here is an application level question and it is a field visit oriented question. So visit a site with bolted truss roof and take photographs of 3 truss joints in close-up. Decide which bolts will be in single shear and which bolts will be in double shear. Prepare dimensioned drawings of the joints by actually measuring the dimensions on site. So do this exercise by visiting a real site of steel structure. Now, if you have understood what is to be done, let us continue to watch the video. So friends, we now come to the last slide of the video where we have to sum up whatever we have learned. So we have designed a bolted connection for truss joint with the help of a complete numerical problem considering 2 parts. We will recollect that we had the expected learning outcome of this video as design a bolted connection for a truss joint. Now we use some key terms also which are again repeated here. It is expected that you have understood these key terms as well as you have attained the learning outcome from this video. If you have got any doubts or queries, you have to contact your teacher. Then as a summative assessment quiz, you have to answer the online summative quiz in the form of the Google quiz as usual given by the teacher. So you have to assess yourself and take care that you solve all the questions correctly. So with this, we come to the end of this video. Thanks for watching the video and goodbye till the next lecture.